What's up guys, it's Brad from That Architect here. In this video, I'm going to show you how you can create building destructions inside of Blender utilizing cell fracture, rigid bodies, rigid body constraints, and of course finishing off with an explosion and debris fields utilizing chaos in a MantaFlow simulation. This video should be pretty straightforward, but I have decided to break it up into two videos. This first one will cover the rigid body simulation and constraints, and the second one will cover the addition of the debris fields and fuel explosion utilizing chaos with MantaFlow. Anyways guys, let's get started. Here we are inside of Blender. This is going to be our starting point for the scene. As you can see, we have a nuclear power plant here. This is from our City Builder 3D asset-based add-on, and we've just imported our cooling tower as well as our nuclear power station here. Through our industrial assets here, we have our nuclear reactor building, and then we have our cooling tower. And as you can see here, you can just add these to your scene. Just click off to the side and they'll come in, and you can put them wherever you want, but you can use whatever buildings you want, but we thought this would be a cool example for this tutorial. Keep in mind that whatever building you are using, the geometry should be sealed, and what that means is that the mesh and the geometry should be watertight so that whenever we use cell fracture on the object, there won't be any glitches. This specific model in City Builder 3D is sealed, and a lot of other professional 3D models out there are also sealed, but just keep that in mind. If you get glitches when you do the cell fracture, that is likely the reason, and you may have to do some retopology to make sure that model is watertight. Anyways, for this tutorial, we are going to be shattering this top portion of the nuclear power plant. So the first step we need to take is separate the top geometry of the nuclear power plant from the bottom geometry. So what we're going to do is we're going to use a few Boolean modifiers. So what we're going to do is we're going to press Shift A, and we're going to add a cube to our scene, and we're just going to cut out a portion of this cooling tower to be what we're going to fracture. So I might go here under our cube settings and turn it into a wire so that we can easily see what we're going to break off. And this is just that initial portion that we're going to turn into a rigid body simulation that we will shatter later. Something like maybe the top half of the tower, and then we can go into edit mode to create a little bit more edges at the bottom portion of the scene here. So maybe I'll add a loop cut here, several loop cuts here maybe. Now what we can do is grab some of these and maybe make a little bit more of a jagged edge for our geometry. You know, you could just use the cube, but if you want to have a little bit more of a realistic break, you can create something like this. Or you could just use the cube, which I've done several times as well, but you can just create some interesting shapes with the Boolean. I might pull these pieces over, create some more jagged edges. And as I said, what we're going to do is we're going to be using this cube to select the portion of the cooling tower that we want to separate from the main geometry. So this is looking pretty cool. We have a substantial amount of geometry displaced using our cube here. So now we'll go ahead and select the cooling tower, and we're going to duplicate it. So now we have two cooling towers in our scene, and we're going to select the first one and go to modifiers, and then go to add modifier Boolean, and then we will select the cube. And now as you can see here, the cube is cutting out the portion where it intersects, and we're going to be using the difference operation for this cooling tower. So we'll go ahead and press apply, and now this cooling tower, as you can see here, is just the portion that will not be fractured and will be a passive rigid body simulation. And now we will select the second cooling tower up here that is still in its entirety, and we will go back to the modifier tab, go to add modifier Boolean, and we're going to again select the cube that we've added as our Boolean object. But instead of using the difference operation, we will use, I think, intersect. Yes, intersect. So now the object is only going to keep everything that intersects with our cube here. So in other words, the rest of the cooling tower in the scene. So we'll go ahead and apply that as well. And now we can go ahead and delete our cube. And as you can see here, we have a complete cooling tower, but it's broken into pieces so that we can shatter one of them and leave the other one alone in our scene. All right, so now that we have separated the geometry that we want to fracture, we want to use the grease pencil to define how we want to shatter this object. So what we're going to do is we're going to go here to Annotation Pencil, and I'll go to this sidebar here, go to Tool, and then under Active Tool, under Annotate, we're going to change the placement to Surface. And what that's going to do is it's going to make sure that whenever we draw our annotations on the scene, it's going to be drawing on the geometry we have in the scene. So in other words, this piece of geometry that we've just separated of the cooling tower. So now what we can do is we'll just, add some annotations on this cooling tower. Essentially, the more annotations you add to an area, the more it's going to shatter those pieces. I'm not going to get into what exactly this does, but I think it's pretty self-explanatory. If we add a lot of annotations, it's going to fracture that area a lot more. And yeah, that's pretty much all I know about it. But just kind of create some cool patterns here. It's not going to be exactly how it's fractured. It's more of just a guideline for self-fracture to know how much you want to shatter a specific object in specific areas. You know, I like to have maybe one main area that I want to shatter more than the rest, and then I'll just have maybe some big chunks here off to the side. And don't worry about if, you know, the annotation goes off the object. We're going to delete the annotation later so it won't be too messy. Alright, so this is looking pretty good. I'm happy with this, but depending on what you're going for, you may want to have a different pattern. I know it looks like a mess right now, but it's all going to make sense here in a second when we fracture our object here. So now let's go ahead and fracture our object using this Annotation Pencil data. So we'll make sure that our fragmented object is selected, and now we will go to Object, Quick Effects, and we'll go to self-fracture. However, if you don't see this option, that's likely because self-fracture is not enabled on your computer. So we'll just go to Edit, Preferences, and then under Add-ons here, just search for self-fracture and make sure that the checkbox here is enabled, and then that will give you access to it under the menu system in Blender. Now again, we'll select our cooling tower fragment, go to Object, Quick Effects, and self-fracture. And now this little window will pop up. We can kind of change some of the settings for our scene, and I'm going to select the Annotation Pencil option here. And there are a lot of different settings here, but I honestly don't know what all of them do. The things that we will be changing in this tutorial are the source limit and the recursion. I'll go ahead and change the source limit to maybe, we'll try something like 180. And that's just going to increase the number of input points to 180, so it's just going to fracture this object more times. Honestly, I would probably do more, but I'm working on my MacBook, so if I do too much, it really slows down. But you can do more or less depending on the look you're going for. The next thing I'm going to add is the recursion. And what recursion is going to do is it's going to fracture the objects again once they have been fractured initially. So if you want the pieces smaller or certain areas to have a little bit more variation, you can increase this, and we'll try 2. Again, I'm not going to go too high because it might just, you know, crash my computer or something. But pretty much what this does is it just breaks the shards even more. Alright, so now that we have our settings here, we'll just go ahead and press OK. And now, as you can see here, our object is being shattered by the self-fracture algorithm. It's looking pretty cool. We have some artifacts going on here, and that's just because our original object is on top of our fractured object. So what we'll do here is we can just move this guy up maybe 20, get it out of the way, and now we just have our fractured object in the scene here. And we can go to the View tab here on the right side and go to Annotations and delete our annotations using that little minus button. So now, as you can see, we have the fractured part of our cooling tower, and if we go to rendered mode really quick, you can see that, you know, if we turn wireframe off here, you don't really see the shattered segments yet, but we will once we turn it into a rigid body simulation and shatter it. So now that we have fractured the top part of our cooling tower, it's time to set up our rigid body simulation. So the first thing we're going to do is we are going to add some passive rigid bodies to the scene for our active rigid bodies to interact with. So what we're going to do is we're going to select the cooling tower, and we'll go to the Physics Properties tab here, and we'll click on rigid body, and we'll change this to passive, and we'll change the shape to mesh. And what a passive rigid body is it's just something that the other rigid bodies will interact with, but gravity doesn't affect. Alright, so now that we've done that to the rest of the cooling tower, let's go ahead and select our floor here and also add some rigid body settings to it. And as you can see here, I already have enabled the collision setting on this ground plane as well, but I'll go ahead and just delete that so that we can add those later so that we can all be on the same page from this starting point. Alright, so let's add a rigid body here, and then we will change the type to passive, and again change the shape to mesh. And now, as you can see, when we play through everything, nothing should move. This is just going to make sure that all the active rigid bodies that we add to our scene interact with our ground plane. And for the sake of this tutorial, I don't think our shattered objects are going to interact with this nuclear reactor building, but they might, so I'll go ahead and select the nuclear reactor building as well, and also add it as a rigid body. Change the type to passive, and change the shape to mesh. Alright, now let's add our active rigid bodies. So what we'll do is we'll go ahead and just select all of the rigid bodies on the top here. We'll deselect our cooling tower, and now instead of using these settings over here to add the rigid bodies, what we want to do, since we want all of the selected objects to be added as rigid bodies instead of just one object, we will go to Object and then go to Rigid Body and then Add Active. And now as you can see here, all of the fractured pieces that we have selected all have active rigid body settings in the physics tab here. And as you can see here, if we play through the scene, we already have a cool looking rigid body simulation. Of course, we're going to add some constraints and play around with the physics a bit, but this is a nice start right off the bat to get a pretty cool looking result. Alright, so this is a pretty nice start, but we don't want these objects to fracture as soon as the scene starts. So what we're going to do is we are going to make these active rigid bodies start deactivated so that they stay in place, and then we are going to animate another rigid body going through them so that they collapse on that moment. So what we're going to do is, while these rigid bodies are selected, we'll go to our rigid body settings here, and under the dynamic section we can see that there is a button called deactivation here, and when we click this by itself, it's only going to deactivate the active object. So in other words, it's only going to deactivate one of the rigid bodies in the scene, but of course we want to deactivate all of the selected fractured objects here. So there is a trick for that. Fortunately, I just figured this out while you are changing any of your settings here with the selected fractured objects here. All you have to do is, if you're on Mac, you can press Option, or if you are on PC, you can hold Alt. So since I'm on Mac, I will hold Option, and while all of our fractured objects are selected, I will select deactivation, and then I will also select, while Option is selected on the keyboard, I'll select Start Deactivated. And now as you can see here, all of our objects that are selected will start deactivated until an object actually hits them, which we will add in a second. But that is a very crucial quick tip for a lot of these settings you can change for rigid bodies, because otherwise you're going to have to select each fractured object individually and start changing those settings, and that's really a pain, especially when you have 100 fractured objects here and it's hard to select them. So yeah, that's definitely a trick that helped me a lot. Alright, so now that we have them deactivated, let's go ahead and adjust the mass for all of our fractured objects here. So I will go to Object, Rigid Body, and I'll go to Calculate Mass. And again, when I click on Calculate Mask, I will hold Option or Alt if you are on Windows and select that. And I'm still holding Options as I'm choosing the type of material that I want these fractured objects to have. So I will use the concrete material, since I believe these nuclear cooling towers are made from concrete. So I'll go ahead and select it. And now as you can see here, if we select any of our individual objects, you can notice that the mass is different for each individual object, and that's just because, of course, they are different sizes and Blender is going to calculate their mass depending on their size. Alright, so now that we have set up our general rigid body simulation, let's go ahead and set up our rigid body to crash through it and create the destruction. So what we will do is we'll select off to the side here and we'll press Shift A, and we will add a icosphere. And depending on how you want to frame your shot for the final render, I kind of want a shot kind of low angle here, so I want the rigid bodies to kind of collapse down here in the foreground. So what I'm going to do is I'm going to animate this icosphere going through our tower here, and I'll go to frame 1 here, press I, add a location rotation scale keyframe, and then I'll go maybe 2 seconds forward, frame 70. I'll grab our icosphere again and push it through our object, and again we'll press I, add a location rotation scale keyframe, and let's see how that's looking. Make sure it goes through our object. That looks about right. Alright, so we're going to go for that for now. We can change this later when we're baking our rigid body simulation. So now what we're going to do is we are going to turn this icosphere into its own rigid body so that it will interact with our fractured object here. So while our icosphere is selected, we'll select rigid body in our physics properties tab here, and we will turn it into an animated rigid body. And as you can see, now we have some nice destruction of our nuclear power plant, and it's already looking pretty awesome. I do want to add a little bit more force to our simulation here, so what I'm going to do is I'm going to just grab our keyframe here for our icosphere, and I'm just going to make that object move a bit faster. So I'll bring it down to frame 50, try this out. Of course, there are, so many different things you can mess with here, but I think this is looking pretty good for the sake of this tutorial, so I'm going to continue, but feel free to experiment with different rigid bodies colliding. All right, so the final thing we're going to do regarding the destruction of the cooling tower here is constrain these rigid bodies so that they interact a little bit more realistically. So what we're going to do is we are going to select all of our fractured elements here, deselect our cooling tower, go ahead and press Shift and make sure that one of the fractured portions is your active rigid body. And connecting these all together with some constraints is actually pretty easy. What you do is you just go to Object, Rigid Body, and then down here we have a Connect option. So we will go ahead and press Connect. And now, as you can see here, in between our fractured objects, we have a whole bunch of empties here, which are constraining our rigid bodies. And when we play through our scene, it's going to act a little bit differently. And as you can see, when we play through it now, the objects are breaking, but they are being constrained together in a little bit more realistic way. Of course, this is not entirely what we want, as we're just seeing cracks in a wall at this point. But our next step is to select all of our constraints and change these settings so that we get some destruction and some of the wall just kind of holds together. So now let's go ahead and select all of our rigid body constraints here. Deselect whatever you don't want selected, obviously, and then make sure that your active object is one of the constraints. And now what we're going to do is under our physics tab here, we can change our rigid body constraint settings. And what we want to do is we want to make these constraints breakable. So again, just like we did for our rigid bodies, we want to hold down Option for Mac or Alt for Windows as we change any of these settings, so that all of the constraints that are selected are also getting the changes that we make on our active constraint here. So I'll go ahead and press Option as I select breakable. And now the main thing you want to experiment with here is the threshold that will cause the constraint to break. So again, while Option is selected, we can increase the threshold to maybe 40. And what that's going to do is it's going to increase the force that is required for these constraints to break and the object to shatter entirely. So now, as you can see here, if we play through our scene, some of the objects are not broken, but some of the objects definitely fell to the ground here. So it's a lot more realistic of a way to shatter something. As you can see here, some of these objects stay together even after the initial hit, versus before we added the constraint, everything was just shattering all at once and it wasn't quite as realistic. So let's go ahead and increase the threshold for the breakable option even more. So again, I will just hold Option or Alt if you're on Windows, and we'll increase the threshold maybe to something like, we'll try something crazy like 100 maybe. And now we'll play through this again. And that's kind of cool. You get kind of a delay and then kind of a shattering here at the end. Unfortunately, we're getting some weird artifacts over here. Not a lot you can do about that other than, just keep tweaking the settings. But, it kind of looks like some rebar, so it might actually end up working. But this is essentially what you're going to be doing. You're just going to be playing around with the threshold. Again, making sure that you are changing the constraints in a way that makes sense and holding down Option so that all of the constraints that you have selected are taking on those same properties. I'm going to maybe just decrease the threshold a little bit. Maybe we'll try something like 50. Again, I'm holding Option down, play through it. Might even try even less this next time. Change it to maybe 34. Let's try that. At this point, it's kind of up to you guys how fast you want your objects to break, but this is how you would do it. As you can see, if we bring it up to 145, it kind of crumbles down later in the scene, which is kind of cool. It's going to fall. It's just like straining its structural integrity, and then eventually it just totally falls down. But anyways, just play around with those settings. I'll leave mine at 45 for the sake of this tutorial. But another thing you can do is you can use multiple constraints to constrain different fractured objects together a little bit stronger. So I'm going to just select all of our constraints here that we've added so far. I'm just going to add them to a collection. I'll press M, add them to a new collection. We'll call them Constraints 1. Now we can just see our scene a little bit better here. And now I might just turn these off for a second or hide them from the scene. We can adjust them later since they're all in that one collection. But if you want a little bonus for the scene and make an even more realistic result, you can constrain maybe the bottom portion of these objects that are right next to our main cooling tower a little bit stronger. So what we can do is we can go to wireframe real quick, and we can select all of the objects here at the bottom, something like this maybe, just for the sake of this example. And while they are selected, we'll just go to Object, Rigid Body, Connect. And now, as you can see, there are some more constraints added here. We'll go ahead and select all of these constraints and make sure one of them is the active object. We'll make these breakable as well, and we'll make the threshold a lot higher. So we'll make these, maybe we'll put at 120, for example. And now, as you can see here, if we play through this, well, it didn't quite do what I wanted it to. Let's go ahead and increase the threshold a bit, maybe. We'll increase it to 489. Now we'll try it out again. And now, as you can see, some of the objects are constrained way more than the rest of the objects, which is, of course, you know, a little bit more realistic, and I think it's a pretty nice looking result. So again, we've added one set of constraints for the overall fracture simulation, and then we've added another set of constraints only constraining this bottom portion of objects to the rest of our nuclear cooling tower. Anyways guys, once you are happy with your rigid body simulation, what you can do is you can go to the Scene Properties tab here, go to Rigid Body World, go to Cache under the Rigid Body World, choose your simulation start and end frames, and then bake your cache. And now your rigid body simulation is baked into the scene, and you can you know, kind of select where you want to see it in real time and continue with the rest of your setup. Anyways guys, that's it for this first part of the video. In the second part of this video, again, I'll be showing you how you can add your explosion and debris fields utilizing the Chaos add-on in a Manticore simulation. So I'll put that link on this video as well. I hope this video was helpful, and I'll see you in the next one.